Finally, let's look at real-world power data from online games. One clear conclusion is that frame rate has a significant impact on power consumption. Across multiple games, power consumption is around 1600 milliwatts at 30 FPS, but often rises to 2800 milliwatts or higher at 60 FPS. In combat or complex scenes, power consumption increases even further. Based on a large volume of collected data, we provide the following empirical reference values. These are not strict recommendations, but benchmarks for comparison. GPU power around 400 milliwatts, CPU, 3 cores combined, around 1000 milliwatts, bandwidth-related power within 500 milliwatts, display power preferably below 200 milliwatt, and other components around 400 milliwatts. Keeping total power consumption under 2500 milliwatts is generally a desirable target. Of course, different projects may vary, and these values should be interpreted in the context of actual project requirements. Finally, here are some practical considerations for power data collection and analysis. First, we recommend using 30 FPS as the standard test frame rate. Higher frame rates may cause overheating and thermal throttling, leading to unstable test conditions and inaccurate comparisons. Second, keep screen brightness and refresh rate consistent during testing, as both directly affect power consumption. Third, perform extensive A/B testing. For GPU analysis, disable post-processing or shadows individually, compare power before and after changes, and verify whether results match expectations. If CPU power is identified as the main issue, prioritize profiling module execution time and check for abnormal time distribution on main or worker threads. For heavy computation, use the job system to distribute work across multiple cores. If GPU power is excessive, use God Online or Gears to inspect GPU counters, such as fragment shader load or bandwidth pressure. When issues are narrowed down to shaders, frame capture is usually required. We recommend using RenderDoc, packaging with OpenGL, and collecting GPU data via Qualcomm tools for more reliable results. By sorting GPU time, you can identify the most expensive draw calls and quickly locate performance bottlenecks. Frame capture in Xcode is conceptually similar to RenderDoc. Overall, power optimization is not a one-time task, but an iterative process requiring extensive comparison and data analysis. We are continuing our research and hope to further integrate quantitative power analysis tools such as power rails into our future products. That concludes today's presentation. Thank you all.